Guys, attendance enabled. So, I think you guys have followed the mail chain, right? And there's really nothing that I could do. I was offered some slots, and then later I realized that those slots are not available. So there's actually nothing that I can do. Um, I had two questions in my mind for the lab this week. Um, so I mean, I can probably just give tell you guys what the questions were. I have not written them down in the proper document format, right? Whatever I prepare for you guys with deliverables and everything. But what I'll do is I'll just type those questions in an email and send it over to you guys. And it's not for submission. Some of you have requested me to give away those questions anyhow, right? You would like to write some code, which is good, right? I mean, which is nice that you would like to write some code. So whatever questions I had, I'll just write them in an email and send it over to you guys. Okay. And then that's just for your practice. The idea was to test your skills related to writing loops. That was the uh, idea for this particular week. I feel it was a very simple problem. Um, but I also have to understand that many of you will have issues in writing loops even right now. So the idea was to give you a problem where your loop concepts would have been tested. So I'll just type that problem in an email and that the two problems in an email and send it over to you guys. You can just write some code for it on your own for practice. It's not a evaluated assignment because I don't think TAs have been able to evaluate all the submissions for the previous assignment as of now, right? So I'm not really planning to burden them even further. So we'll just treat that like a practice set or something. Just two questions there. So I'll put them on an email and send it over to you guys. Okay. The attendance is open. We can put it up. We can wait probably for a minute or so. Okay, I guess uh, we're not going to have any more people. It's early in the morning, right? What exactly is the attendance percentage for this slot? Are people there in this slot? Because I only have it on Tuesdays. Otherwise, my classes start at 10. And how many responses? Oh, this is interesting. I only have 50 people, but uh, I have attendance for 56. Great. Uh, so at least it looks like some of you might have just put the attendance and then gone back to sleep, is it? Anyhow, just a minute. So I guess we can start with whatever uh, whatever attendance we have. Okay, so let me just open my sheet. Where is it? Mhm. Okay, volunteers. Today we are going to discuss is lecture 8.2, that is on structures actually. Again, just like functions, this too is a two-part lecture. I've broken it down into two parts. The first part is covered in this week. The second part will be covered in the next week. Oh, is it? Sorry. Let me check. Uh,
Sir, you are audible, sir.
oh, okay. Sahil, this might be something at your end. Sometimes it's at my end. Most of the time, it is at my end. It looks like uh, WebEx doesn't agree with me too much. Yeah, yeah, maybe. Uh, yeah, volunteers, guys. Jay, Sudeep. There was one more person yesterday. Jay, other than you, who was there? Who wanted to be a shepherd yesterday? I said you could be tomorrow. Okay, okay. Let me add your names first. Jay, your roll number and section. Just a minute. Where exactly is that? Write it. Okay. CS16. Okay, Deepika, you could be another one. Just a minute. Let me add Jay's name first. CS16. 16, 16, 16. Okay, and Sudeep,
Sir, CSAI 2.
CSAI 2. Okay, just a minute. 2. Okay, got it. And Deepika, your roll number and your section. Uh, AI 59. Okay, 59. Okay, got it. Okay. Any more volunteers? I can do with three, but if there are any more, I can add them. Okay, no more volunteers. Okay, fine. I guess three is not a bad number. Of course, everyone. Uh, Sahil, your internet connection is having some issues today, right? Uh, don't worry. Just I think you could probably try to rejoin. Uh, for meal. Sorry, Deepika, I didn't get this point. You were not volunteering for shepherding, is it? You were volunteering for something else, is it? Oh, you wanted the attendance, is it? Uh, then send an email. Sorry, I've marked you as a shepherd. Sorry. Uh, I'll just remove it. Mm, okay. So then I would be happy if I get at least one more shepherd. Where are all my uh, volunteers who are always ready? I need at least one more. Otherwise I'll have to pick one randomly, and I'm not sure everyone will be happy with that. Okay, fine. So let's just say Jay and Sudeep, you are having more responsibility today. So you are the only two shepherds, and I don't want to actually select someone like this randomly. So let's start, guys.
Sir, I could be a shepherd.
Okay. Roll number and section.
Sir, AI 18.
AI 18. Just a minute. AI 18. Okay. Okay. Thank you, Vishnu. Let's start then. I'll share my screen. Sorry, I'm not too well today, so my voice may not be that good. Uh, so can you guys see my screen?
Yes,
Yes,
sir.
sir.
Okay, guys. So you can start. I'll just mute myself.
I can take up the
Okay.
first question.
Okay.
Yeah, so we have studied arrays. In arrays, we can store variables of same data type. But if we want to store variables of other data types together, like int, character, or float together, so we are using structures for that.
Yeah, so basically it's the just the same as creating an array, but instead of each element being of the same type, we can basically choose what type of element we want. It can be a char, a float, an int, or whatever we want.
In arrays, we have to define the size, but in structures, we do not have to define the size of the structure.
Okay. Thank So is this point clear? The difference between an array and a structure? When exactly are you going to use an array and exactly are you going to use a structure? Is this point clear? Anyone has any doubts? So as you guys have said, so basically whenever you want different types of data types, you would like to use a structure data, so then you would use a structure, and otherwise you are going to use a an array, right? So array you guys have already used, you understand how it works. So that is the broad difference. I don't think it is that difficult to understand, but still, okay, I guess it's clear. So we can move to the next question, guys.
Member variables are like the data elements of the structure. You can define in the braces like string, a character, float, or integer, and the structure variables are the actual uh, parameters of the structure which are used to access the elements. There is a dot operator between the structure variable and the member variable to access the exact uh, structure variable's member variable.
Yeah, so first we will write struct and then space and like sample structure. So this whole thing becomes like a data type. And then we start with the braces and declare variables inside those braces. These are called the member variables like int I, float f, char c. These are the member variables. Now, if we want to access or initialize any of the variable from these, we will use another variable like s1, for example, like struct sample structures. Then we will write s1. So S1 is the structure variable which we can use to access the member variables. Or we can assign values to it using the S1, which is the structure variable.
Yeah, so the best way I like to think about this is I try to compare it to arrays where each element of the array is analogously the same as the member variables for each instance of the structure. So each member variable is basically the same as an element of an array. And the only difference in how we access it is instead of using an index, we just use the dot operator and use the name of the member variable. While the structure variable itself is basically just using the structured like the type that we created earlier, the template, and then you declaring a name with it. So that's basically the structure variable.
Sir, I had one question. If we want, suppose we want to create a structure which has an array, integer array. So, do we mention the size of the integer array when we are declaring the structure?
Yes, I mean to the best of my knowledge, yes. Again, the modern compilers, they may actually allow you a lot of things, but you have to declare it the size there then and there itself. You can use some constant for it. So, for example, you can do something like a hash define something and something like that. But from what I understand, it has to be the size has to be given there. Why? Because when you actually create a variable of that particular, so when you create a structure variable, as far as I know, there is really no way to provide that information at that instance, right? So it's like this. Let us say if the name of the structure is s or something like this. When you create a variable, a structure variable, you simply write struct s1, right? This, right? I mean, there is really no way to provide any more information about the member variables. Okay, so there is nothing like a, for example, if we go to the object oriented domain, there is no equivalent of a constructor with a structure, right? So that is why you cannot parameterize it. You cannot change the elements of a particular instance of a structure on the fly. This is the problem. So you have to give the size of the array. Again, as I said, right, uh, these days I don't give out a statement very strongly, because there might be some differences that the new compilers may have added. uh, yeah, yes, Neil, it's pretty much like that. In fact, this is what you should see, that in whatever you want to do with not just in Java, you probably a better comparison is with C++, that a structure is pretty much like a class, but it doesn't have any methods in it. Okay, it only has just the member variables. So yeah, Shashwat. Logically, I do not see any other way in which I can actually provide the size of the array at the time of creating the structure variable. So this seems to be the logical way, right? That you have to provide the size then and there. Of course, you can always use a pointer, right? So, for example, if you want an array of variable size, you can always create an int asterisk arr within the structure, and then later onwards, after creating the structure variable, you can use something like malloc
Yes,
to
sir.
yeah. Go ahead.
Yes,
You
sir.
had some, yeah. Okay.
And
Okay. Okay, guys. Yeah. Go ahead, guys.
Yeah, so in the third question, it is possible to use array as a member variable. Like in the slides also, we saw an example of the passenger vehicle car. So inside the structure, the array was declared of character name, then the size of the array. So it is possible.
You can declare a array of int, float, and strings inside the structure, and you can access them by the structure variable dot the name of the array. You have to define the size of the array in each of these.
Yeah, an array can be declared inside a structure as a member variable, and it can be accessed using the dot operator.
So, just to summarize, basically, a structure is kind of a it's kind of a container, and this container can also contain arrays. This is the idea, right? It's not just for basic elements, not just for char, int, float, double kind of thing. You can have arrays within a structure as well as member variables. So, and in that case, let us say the name of the array is ARR, and you have just created a structure variable for this structure, let us say called S1, then if you want to access a particular element of the array, you do something like S1 dot ARR and then in square brackets I, right? So that is the idea. Okay, any queries, any clarifications on this? Okay, you guys can move to the next question.
The
It
answer
is
to the
pos
okay, you can go ahead.
So it is possible to create the structure type array. So what will happen in that is we write struct, then sample structures, then so this is basically data type, and then we write the array name like ARR, and in the bracket we write the size like 3. So what happens is that now the first index of the array will be like a structure. So we can store everything what a structure can do in the first index, and then similarly in the second index. So then size of the first index will become with like the size of the whole structure. You can continue.
Yeah, so
You can access
yeah, go.
the you can access the structure variables by using an array. You have to create a lot of variables. Then you can use a structure of an array of structures. So uh, in this you have to, like Jay said, when we define an array, then in order to access it we can use the structure, a data type struct, suppose struct book, and then b, and in the subscript like I and dot operator, and then the member variables.
Yeah, so when we declare, if we declare an array which in the format of like writing the struct name and then array, and let's say we have a size of 2, so that basically creates each variable twice, and they can be accessed separately using the proper index.
Uh, so you can, I think you guys now understand the syntax really. So if you have an array within a structure as a member variable, you will write something like this: s1 dot arr I. So this is basically accessing the ith element of the arr member variable, which is part of the s1 structure variable. And let us say you have now created an array of structure variables, and there is some element in, there is some member variable, let us say called arr itself. So then you will have something like this, um, sarr, let us say it means structure arr, I dot arr j. So I just want you guys to understand that what do these two expressions mean. Okay, the first one is basically a structure variable, and there is a member variable called arr, which is essentially an array. And if you want to access the ith element of that array, this is how you write it: s1 dot arr and then in square brackets I. And similarly, you can also create an array of the structure variables themselves as well, right? So in that case, the first subscript, in the first square brackets, they actually tell you which structure variable am I talking about, and then the dot, and then the member variable for that structure variable, and then the second subscript, which basically says jth element of this array. So if you guys have any queries related to this, you can ask now. Uh, Otherwise, we can move ahead. Okay, I guess we can move ahead, guys. Okay, there is some question. Uh, uh, I don't think you can actually. So this syntax itself is problematic. You cannot put this. You cannot put this 10 there actually. Um, so let me also tell you that whatever you have written, um, this is basically the declaration of the structure. You are not really creating a structure variable here. Okay, whenever you are doing it something like this, struct. In fact, let me use the Word document. Mm, so when you create the structure, you do it like this: struct name of the structure. Let us say student. Mm, Start using some other uh, some text editor probably. Struct student. Then let us say, what have you declared? Uh, Roll number and char name. Okay, yeah. So you do it like this: int roll. Just assume it is small. Okay. Int roll and char name 10. Okay, so this much is the part where you are creating the structure. This is basically the template declaration. And then when you create a structure variable, you do it like this. What have you written? Okay, you have not written anything. So then you create like this: student s1. So this is now an instance of this structure. Okay. If you want to create an array of this, you simply put it like this. Um, Students, let's call it all students, and then you say uh, 120. So let us say there are 120 students and you want to store information for all of them. Then uh, this is the syntax. You can do something like this, by the way. You can create something like this here. This essentially means it not so this is like a shortcut where not only are you declaring this to the structure student, you are also creating a structure variable s1 simultaneously. Okay? So this is more of a shortcut, but because I usually define the structure in a header file, so I don't use this notation. Okay, because I use this. So this is the overall idea. Any questions, guys? Okay, Rahul has a
Sir,
question.
sir,
Yeah, go ahead.
sir, can the structures be nested? Sir,
Yes, they can be nested. I have not tried defining it then and there itself, but it is certainly possible to do something like this. Let us say you can create something like this: struct marks. Uh, and there you let us say do something like this: int ITP, uh, int maths, like something like this. So let us say I'm storing some two values, right? So this is I can do this certainly. Struct uh, marks for student. So this is allowed. Of course, you have to follow the same things that you do for us for a function. So the declaration for this has to be before this. Okay, otherwise your compiler will simply complain, I don't know what is marks. Okay, uh, sorry, there has to be a semicolon here. um, I have not tried copying this here. Okay, I don't think it would work. Okay, to the best of my knowledge. But again, sometimes I these days I refrain from making such questions, such comments. You can try, right? Whether this, putting this here directly, whether this works or not, that I'm not sure. Um, but this one certainly works. This works guaranteed. Okay, this I don't know whether copying this here will work or not. That I don't know, because essentially what happens is then this struct marks, you cannot create an instance of struct marks without creating an instance of student. Okay, so this I am not sure whether C allows or not. To the best of my knowledge, it will not allow it. You will have to create the structure separately, because otherwise, in for example, in object oriented programming, um, it makes sense to simply put this sorry inside this particular structure, because I might want to hide it from the rest of the world. But here we are not hiding anything, so I don't think it will be allowed. But still, just try it out. Just copy this whole thing here at this point, and then see what happens. Okay, but most probably it should not work. Okay, let me get back to the chats. Any more questions
sir,
on this? Yeah.
sir, in order to access the ITP, uh, the, uh,
Mhm.
we have used two dot operators now.
Yes, 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 yes. In order to use ITP, you'll use something like this. Uh, all okay. I'll just say this is easier. Let me just create S1 here. Then, in order to access ITP, you have to do S1 dot marks for student dot ITP. This is how you access ITP. Okay, so there are two dot operators.
Okay, sir.
But make sure that you don't put marks here. Okay. Here it has to be the name of the structure variable, not the name of the structure. So if you replace this with marks, for example, this is wrong. It has to be marks for student. The name of the structure variable, which is defined as a member variable of student, that has to be put here. Okay. Yeah. Any more queries on this? So you can do nesting. Mhm. It's very simple to a header file still contains only C code itself. Okay. Usually a header file does not have a main function, because the idea is that you are putting some declarations or definitions in a header file which you would like to import into multiple C programs. Okay, so you just extract that part into a different file and you call it a header file. So um, in theory, it a .h file is not different from a .c file. They both contain C code. It is more of a convention that if I am creating a header file, it gives me an idea that this file does not really contain executable code. This is something that will be imported into other programs and then used. That is the idea, right? It's exactly the same as a C file. You just name it as a header file, .h file, instead of a .c file. Any more queries, guys? That is I think I put it in the homework. I guess it might be in the homework. So you have to figure this part out, because it's like this. In one of the programs, you would see something like this: uh, hash include stdio.h, and then at the same time it will be something like hash include uh, I don't remember the name of the header file, but it would be something like this, some.h. There is a difference here, right? You can see that the second header file is included in quotes, whereas the first header file is car.h. Yeah, thanks, Steve. So while the first header file stdio.h is enclosed in this, right, and the second one is enclosed in this, and this is not an accident. Okay, there is a reasoning behind it. When do I use the first one and when do I use the second one? And that is your homework. Okay, you have to find out why I used this for the two cases. But Nehal, it will answer your question. If you find the answer to this, it will answer your question. Yes, so it's not just user. Okay, so basically we have discussed the homework as well. It is not user created as such. It's basically it's going to be in the same. So it's like this, where there is something known as an include folder. So every compiler has a place on your hard drive where your include files are kept. Okay, /usr/include, something like this. Okay, mostly I think it is there /usr/include or something like that. So there all your stdio.h and math.h and all those header files, they are stored there. If you use this notation, it tells the compiler that please look for the header file in the include folder. If you use this notation, it means that look for the header file in the current folder. Okay, so that is the only difference. And you are right, right? So usually the user defined files will be somewhere relative to your current folder. So by the way, you can do something like this. You can also create a folder within your current files folder and call it, let us say, include. So in which case you write something like this: include um, include slash. This is also fine. Okay, so basically this means that there is a header file called car.h which is present in the include subdirectory of the current directory. So basically the codes just are a way to tell that this is yes, Nehal, that is pretty much the same, the dot slash. So it means that look in the current directory. That's it. Okay, so uh, any more queries on structure nesting? Um, member variables and stuff like that. Otherwise, we'll simply move to the passing of structures to functions. Yes, sure. That is the last question, I think. Right? Yeah, that is the last question. And any other question. Leaving aside the function part, that is the last question that the shepherds will take. But any more questions? Okay, fine. So, guys, you can take the last question now. Shepherds, you can take up the last question. Oh, sorry, I scrolled down. This is the question 5 that I think. I think question 4 we have discussed, right? So question 5 is the one that is remaining.
Yeah, so it is same like we did in arrays. We passed the arrays address to pointers. So we can create a function which has arguments as pointers, and we can pass the address of the structure by calling a function. That is basically passing it by reference.
The question is that can you do it in both fashions, right? Value as well as reference. What happens when you do it by value, and what happens when you do it by reference? That is the question.
When you will use by value, then you have to use uh, the dot operator in between the calling in the calling sorry in the called function. And when you will use the reference, then you have to use a minus a greater than operator in the called function. And rest is the same, that you have to create a pointer in the called function to store the address of the structure by giving ampersand goes like this ampersand marks. And in the value it is same, the marks, and there we have to use an integer sorry, a struct to store the marks.
Okay, so sorry guys. First of all, I have not yet discussed the pointer to member variable operator. That will be in the second part of the lecture. So Sudeep probably just talked about it. So don't worry about that. So this is just to give you a heads up. So this is another operator in C, minus and greater than sign. We will have a look at it in the next lecture. So next part of the lecture. So don't worry. As of now, so basically the idea is something like this. You can actually pass structure variables to functions exactly the same way as you pass your int, char, float, double, right? And if you go through the lecture slides, there will be a slide where I'm passing structure variables to a function by value, and then there is a function where I'm passing them by reference. So it is exactly the same way. Let us say if you want to pass an integer, how do you do that? Let me just add some more things here. So let us just say you want to pass s1 to a function by value. Then you simply do something like this, func, and you do s1. Okay, so this is passing by value. And what happens is, in the function, uh, struct student. Oh yeah, I need to add one more question for type def. I'll do that just now. I realized s1. So what happens is like something like this. Let me call it something else. Let me call it S2. So what happens is whenever you make this call, what happens is within the uh, if you remember, and this is the part of the third lecture of the week as well. So what happens is some memory is set aside for the func function, and in that func function, a local structure variable is created S2, and all the values from S1 are copied into S2, and we call it member to member copy. So what does it mean by member to member copy? It essentially means you copy, let us say if the value of role from here to here. So this is equivalent of saying something like this: s1 dot roll is equal to s2 dot roll, and what else there, right? S1 dot name. Yeah, the arrays are still a tricky part. S2 dot name, um, because I still don't know exactly what would the modern compilers do with arrays. Okay, whether they simply copy the pointer to the same location, or whether they are going to create uh, another another memory location. So basically, because from the best knowledge that I have, arrays are not really copied member to member. They are, so basically just it is just your it's just the pointer that gets copied. So that part I still don't know. Maybe the modern compilers have evolved enough to also copy arrays, but usually for all the member variables like this, it is simple. It will be done like this in the background. Everything from S1 gets copied into S2. um, Arrays, I am still not sure. Even I will have to check what are the current compilers doing, whether they are going to point to the same array, or whether they are going to create a copy. That I'm not sure. But is this part clear? So basically what is happening is, what do you do with the primitive data types when you pass them by value? A copy of that variable gets created in the called function. So the same thing happens with structures. A copy of your structure variable will be created in the called function. This is pass by value, and in pass by reference, it's again the same thing, that you essentially do something like this. uh, Asterisk. Okay, there comes an asterisk, and from here you pass the address of S1. So it's exactly the same as passing the primitive variables. Yeah, so this was the part that I was trying to highlight, not the uh, not the member to no the pointer to member variable operator. That we will see in the next part of this structure lecture. Okay, queries. So is this part clear? Do you understand what is member to member copy? That when I basically write, and this is not just for pass by value cases. Okay, you can do this is so. For instance, this is a completely valid statement. Uh, S2 equal to S1. Come on, Microsoft Word. This is a completely valid statement. So S2 is another structure variable, S1 is a current structure variable. You can always do S2 equal to S1. This is allowed. Okay, it will simply copy all the values from S1 into S2. The arrays part I will have to check. I don't know what exactly what the compilers do. My best guess is that it might not be doing the member to member copy, but it may be also. I'll have to check. But for non-arrays, it's very simple. It is simply a copying operation from all the members of the RHS to the LHS. Is this part clear? It should not be clear in the first iteration. I mean, it should be confusing. But if it is clear, I am very happy. Okay, looks like it is clear. So I just need you guys to, any more queries, guys? Or is a way of passing it by value? Right. That is the point, though. So essentially, it will copy it. The major issue with copying arrays is that we call it deep copying. Actually, whenever you have to create a clone of an object, also. So this will be applicable to you guys when you use C++ or Java. This whole concept is known as deep clone. Deep clone means I am not only copying the primitive variables. I am basically creating a copy of more complex objects like this, like an array. So, oh, great. Okay, so we now have the answer that arrays too will be copied member to member, which is very nice. Um, so it makes sense also. Otherwise, if I make a change in, I'll have to go and check all the pointer accesses. So it makes sense probably, right? That the compiler will do uh, a good job for me. So and someone was asking, right? Can we actually send arrays by value, right? Someone asked, I guess, in yesterday's lecture. So I think this is great. So you only found the answer. So nice, right? So essentially, arrays too will be copied member to member. And when I say member to member, you understand, right? That let us say there is a 10 member array. In fact, let's go back to the thing. So this, in this case of this char name, right? It is a 10 element array. So whatever is there in the 10 elements of this of S1 will be copied into the 10 elements of S2. This is the idea. Uh, Copied by value, not copied. So see, Jay, the problem is, um, arrays can actually be huge. Okay, and this is in my view, this was the logical reasoning for uh, for having a system where they will never be passed by value. Okay, they will always be passed by reference. But as Nehal pointed out, when you are actually making a copy of a structure variable, and let us say that structure also has an array, what do you do? Okay, you have two options. In the newly created copy, you don't actually allocate those many number of contiguous bytes, but instead you point it to the same array that was already created. But actually that doesn't make any sense, because the size of a structure variable is also fixed. Okay, so you have to create those many bytes within the new structure variable as well, and assign it to the array. So certainly you'll have to create a copy as in you'll have to copy all the elements from the previous structure variable to the new structure variable. That is the idea. And if to give the answer to your question, yes, if you are not enclosing an array within a structure, it will always be passed by reference. But if you enclose it within a structure, then it will be passed by value. Why? Because you are not really passing the array, you are passing the structure variable to the function. Okay, and structure variables can be passed by value. This is the idea. They can be passed by value as well as passed by reference. This is the idea. And that is why we that is I told you guys, right, that I don't know if there is a trick to do it, but the language doesn't allow it directly, and this is the trick. Okay, you enclose it in a structure and then you can pass it by value. So you force the poor compiler to copy the array for you, element by element. Poor thing. uh, so so anyhow, is this part clear? The part of sending a structure variable by value, the idea is very simple. If you send a structure variable by value to a function, a copy of the structure variable is created in the called function, and everything is copied member to member. Okay, whatever is the value of member x in structure variable s1 will be copied to the member x of structure variable s2, including the arrays. That is the idea. Is it clear? And the same thing is true with pass by reference. So in reference, you simply pass the pointer to that structure variable, and then you access it using that asterisk ptr mechanism. Okay, asterisk ptr dot whatever you want to do. Just read the sample code, guys. I mean, this is why I give those sample programs to you. Usually they'll have the example of all the concepts that are provided in the presentation. So it's very important that you guys open up the sample programs. I can see that most of you don't open it. You just read the slides and go ahead. But then it probably defeats the purpose. Okay, and in the beginning I used to put the output of the programs as well, but now sometimes I won't put the output because I expect you guys to run the code and check. Okay, Any more queries? We just have one more thing to talk about. We can just talk about it informally as well. I'll write it. What is the what does the type def? That is the only question that is left. If you guys are done, and if there are no queries, then the shepherds can just take the last question. Okay, shepherds, you can take this one.
Okay, so the type def keyword just changed the name of the data type which we're using to create the structure. Like if we use struct sample structures, so we can replace it by any other variable like car, because we don't want to write this whole big thing again and again. So we can use type def struct sample structures and then the name which we want to replace it with car. So everywhere where we are using struct sample structures, we can replace it with car. And also type def is follows the scope rule also, that for example we created the type def thing inside the main function, and then if we use the changed variable inside the called function, then it will not happen there because it is in the scope of main function only.
Yeah, well, using type def, you need to make sure that you have not mentioned you have not used the type name itself anywhere earlier in the code, and the rest is the same. You just use it to shorten the length of the type names.
And one more point, guys, that type def is not just restricted for structures. So you can always do something like this, type def int and int something like this. Okay, so from there onwards, this and this, they are both equivalent. This is the idea that type def, right? So basically, you're defining a type, and it's more of a convenience. It is usually used with structures because it makes your job easier. It reduces some 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 of your what can I say, typing that you'll have to do. You'll have to type struct every time, so that you can do away with. But it's a generic thing, it's a general thing. You can actually define it like this. In fact, if I'm not wrong, in some libraries they define a boolean variable something like this, that they say, type f uh, uh, char or something like that as bool. I'm not sure, something like this, right? So basically they'll just create a bool, and you can either assign it y or n, something like that. uh, and so basically you do something like this: bool flag equal to y. I'm not sure, right? Something like, or bool flag equal to 0 or something like this. No, Naveed, there is no concept of namespace in C. It's only applicable to C++. Not only name, there are no namespaces, there are no packages, nothing like that in C. C is a very simple language. So everything is basically a part of your program. So this part is clear. So type def is a very simple idea. You simply are creating an alias. Yeah, right. That is one more example given by Karthik, that instead of writing long, you simply write LL. Okay, so I mean, if you start reading header files, okay, there are so many things that you can see. Okay, so just you'll see the use of extern keyword. You'll see the use of type def keyword. So someday just go to that USR local. I'm not sure exactly what folder it will be. Maybe USR local, local include or USR include, something like this, and just open up a few header files. Just check what content they have, and most probably you will find something like this. Okay. Okay, guys. I think we
Sir,
have. Yeah, go ahead.
So what can be the maximum size of a structure, because it depends upon the member variables. So we can add any number of variables in it.
Yeah, it is the same. I mean, it is on the same lines of what can be the size of the array, right? The maximum size of the array. Yes, Nihal, it is kind of the same thing. A hash define is used to do it for constants. Type def is used to do it for types. Okay, I mean, it's like you're defining a new type. A type can be used to create variables. A hash define is used to create a constant. You can put the constant somewhere. Okay. So yeah, coming back to your question, Jay. Um, uh, Sorry, what was your query? I forgot again. Um,
Yes,
Jay,
I got it.
okay, okay.
Size of the structure.
So it is on the same lines of the array, right? I mean, it's mostly dependent on your implementation. How much contiguous space can be allocated to your structure, right? Um, so uh, guide, yeah, okay. Pranav, you have some question. What exactly is this C Leon? Is it uh, some editor or what? Okay, okay, IDE. I don't know. Acha, okay, okay. IDE. I've never used an IDE to write code for C actually. Even when I wrote so much of C code, I never used an IDE. I used to use the Vim actually for all the code. For Java, I use Eclipse, but for C, I have never used. Oh, okay, okay. I've never used it, so it must be good, right? I mean, I think I have seen some people using some Eclipse plugin for C, but I have never used any IDE for C. So, oh, okay, okay, very good. We will discuss GDB by the way towards the end. I just want you guys to understand very basic debugging techniques. But if you are using something like an IDE, probably you don't want to you won't require using GDB. But still, I'll teach you GDB. Just in case you are running it on uh, some uh, server installation. Okay. Yes, yes, you can. It can be used, and in fact, this is Jay. This is the second part of the lecture, where we'll see how you can allocate dynamic memory for structures, and that is actually a very important concept, which will be used in data structures when you study it in the next semester. I think next semester, right? I'm not sure. Uh, yeah, sorry guys, it's already 10. You'll have another class. We'll meet tomorrow. Okay, and no labs today, so don't be worried. Okay, guys, bye.